Hello ladies and gentlemen, welcome to Test-Driven Development Techniques video tutorial. My name is Vasily, I am a professional software engineer. This series of tutorials is intended for developers who want to get into TDD world, but don't know how to start. In these videos, I will show you several approaches that can be used in order to convert product requirements into tested production code, while writing the tests first. So, without further ado, let's get to work. For the purpose of this tutorial, suppose that we are given a real task. Our task is to build a system that manages registrations for driving lessons. One of the requirements of this system is that a candidate can register for driving lessons only if the candidate is 16 years old or older, and either the candidate never had a driving license or his or her driving license is not currently suspended. So these were two original requirements given to us by product people. However, after digging a little bit more, we realized that the information about driving license suspensions is not stored in our system. This information is stored in third-party external system. Therefore, we will need to think about integration as well. These requirements that we see are clearly some kind of a policy. We would like to encapsulate this policy in a standalone class in our design because there is very high chance that this policy is going to be changed in the future. So, I create a new package called registration policy. No, I will call it just registration. And in this package, I'll create a class which is called registration policy. Cool. Registration policy is going to have a method that returns boolean, and the method name will be is allowed to register. And this method gets candidate entity as a parameter and currently returns false, just such that this method compiles. At this point, I stop writing production code and start writing tests. So I create a new test class. I can already start writing test cases. However, before I do that, I want to get back to requirements and ensure that I remember everything correctly. The tests that I write will need to ensure that the system under test enforces age restrictions correctly and that the driving license suspension policy is being implemented as well. So, the first test case will ensure that this method when invoked for a candidate that is of age and has no suspension, returns true. And please note the format of the name of the test cases. The first part of the name describes the tested entity, and in this case it's just one single method name. The second part describes the condition under which this test run. And the third part is the expected result. So I strongly advise you to always follow some kind of pattern when naming your test cases, and this one works very good for me. Also note that the template of the test case that I use already contains those three commands. This is a very common practice to separate the test body into three different stages. The first stage is arrange, where we set up the test environment. The second stage, act, is where we execute the actual system under test. And the third part, assert, is where we put all our assertions about the state after the test is completed. Alright, enough with the explanations, let's write some tests. First of all, we need the candidate which is of age. set his ID to some fake ID, set name to some fake name, and set age to be of age. Build. Great. And now the tricky part. How can we set up this condition of no license suspension for the test? Well, that's where mocking strategies will come in very handy. First of all, let's create a new class and call it license status retriever. This class will have just one single public method for now. Is license suspended? Single argument. And for now it will return constant false. Note that the design, the test, and the implementation of this class is outside the scope of our current discussion. We just need to test the registration policy for now. Let's get back to the test that we are working on and set up a mock for license status retriever. Now, we want that for all tests by default, when this mock is called with any argument, that it will return false, which means that by default we are saying that candidate's license is not suspended. So now with this default no suspension rule and the fact that we have a candidate which is of age, we can finally complete the first test case. And assert that the result returned by system under test is in fact true. First test case is ready and we immediately proceed to writing additional ones. So this test case will test the same entity, this method, but the candidate will be underage without suspension, and since the candidate is underage, this test should return false. 15, the candidate, and returns false. Great, second test case is ready. We already start seeing some code duplication between test cases. So it is a good time to extract some of this code to external constants. So that will be our candidate. And the candidate will not use hard-coded age like this one, but a constant age limit. And the age limit is set to 16, right? That's our requirement. So now this test case can be rewritten as candidate with age limit -1, and this test case can be shortened and rewritten as candidate with age limit +1. Some watchers can be a bit uncomfortable with what's going on right here, because we are testing the age limit +1 and we are testing age limit -1, but we are not testing the age limit itself. And it's widely known that there are just 3 hard problems in computer science: cache invalidation, naming things, and off-by-1 errors. Therefore, in order to eliminate the possibility of off-by-1 error in this case, candidate is exactly of age. We will test that when the candidate is exactly of age, our system under test functions properly. The test cases that we wrote so far tested just the age restriction policy. However, we need to test the suspension policy as well. Therefore, let's add another test case. So the same entity, however now candidate license suspended. And if candidate license suspended, then our system under test should not allow the candidate to register. So yeah, false is the expected value in this case. So how do we set up this test scenario that the license is suspended? Well, we use our mock any, then return true, the license is suspended. The age in this case is not that important, and we need to ensure that our standard candidate is of age. Alright, cool, he is of age. And the test should return false. Cool, that's the correct test case for this scenario. This test method that we just added ensures that the return value of the collaborator object is being used properly. However, we need to add another test case that will ensure that the collaborator object receives the correct parameter from the system under test. So when this method is called, candidate ID passed to collaborators. In order to test this condition, we need an argument captor for class string, right? Great. And we execute the system under test, and now we need to verify that this mock was called and that the argument of this call, assert that argument of this call, that argument capture captured is basically the candidate's ID. How do we assert that? So we would like to change the candidate with some custom ID, and then we want to assert that it is the same test ID. Great. Until now we wrote 5 test cases. 3 of them test age restriction and 2 of them test license suspension policies. It looks like we have enough tests in place in order to test all the requirements, and we can write the actual production code. Let's get back to our production class. This method is currently mocked and we need to convert it to the actual implementation. So first of all, this class should be dependent upon private final license status retriever. Great, yes, please do. And now this method checks that the license is not suspended and that the candidate is of age, right? Just like that. The implementation of this method is complete, but we are not sure it works. So we get back to our test and there seems to be some kind of an error. Yes, sure. We need to pass the mock into our system under test upon construction. Sure, that's true. And then we want to run this test and see the results. Run. One of the tests failed. The candidate exactly of age, no suspension. So when the test fails, the problem may be in the test itself or in the production code. So the test seems alright because we test that exactly at the age limit the candidate should be allowed to register for the driving license. Let's see what's going on in the production code. So when candidate's age is larger than the age limit, now remember we discussed the off by 1 errors, that it is super important to test for them. So here, completely unintentionally, I demonstrated you why it is so fucking important to test for off by 1 errors. I made it here myself. So the candidate that is 16 years old should be allowed to enroll in a driving license. Therefore, this code was wrong And now if we run our test case, all tests pass. This moment, when we see the tests pass for the first time, is a critical moment. At this stage, we might be tempted to just commit everything and push it into the central repository. However, that will be a mistake. What we do need to do at this stage is to go over all the code that we wrote and ensure that it is written properly. So in this case, we can change this to private and add a new line for readability, and the names of the variables are alright, and there is some problem here. Right, there is a problem here. From purely a functional point of view, this code is correct, and we even have tests that ensure that it works. However, note that this code that involves request to some third-party system will always be executed, even if the candidate is underage. In some systems, this inefficiency can create a real performance bottleneck. Therefore, I would like to fix it right now. Remember that we do not write production code without writing tests first. Therefore, even for this small change, I need to come up with some tests that will ensure that I make it properly. So let's get back to our test class and add another test. So this test case is allowed to register, and we would like to ensure that when candidate underage, external system not accessed. Okay, so that's what we want to ensure, that if the candidate is underage, we are not polling the external third-party system. And basically we want to ensure that candidate with age, and we want it to be underage. And the assertion that we would like to make is that there are no more interactions with this mock. If we run our tests now, we can see that this new test fails, and it's alright because the code is currently written not as we would like it to be. So what we do is we just change the code and maybe when I think about it, we even encapsulate this call in a standalone method. Is license suspended and not, that would be the proper way of doing that. So let's run our test cases now. Great, so now all tests passed, and we even made our design a bit better because now the code became more readable. After we reviewed the production code and added the missing test cases, we also need to review the test class, because our tests are first-class citizens and we should invest in them not less than we invest in production code. Write this private, less space please. Great, I like it. And only after we reviewed both the production code and the test case can we open our terminal and commit all the changes. Our review of the first test-driven development technique, which involves writing all tests up front, is complete. And as any other concept in software engineering, this technique has pros and cons. The good thing about this technique of writing all the tests up front is that it is simple to understand. We just need to write all the tests, and then we need to write all the production code, and then we need to debug the tests in order to make them pass, and we are done. The bad thing about this technique of writing all the tests up front is that we basically write all the tests up front and then we write all the production code. So if there are any issues in the tests themselves or in the production code, we will find that there are issues only very late into the cycle when we actually run the tests. And then it might be quite difficult to understand which parts of production code cause fails in which tests. In the next videos of this series, I will demonstrate you the more advanced techniques for test-driven development that resolve these issues. So, thank you very much for watching, and if you found this video interesting or useful, don't forget to like it and subscribe to our channel. Goodbye!